Now this integration was asked by MIT Integration B qualifying exam. So this is just qualifying exam, please keep in mind. So as you know, MIT Integration B has different levels. Now look at this integral we have 0 to pi by 2 x into pi cos of this into dx. Now here this pi is what? This pi is product of this. Okay, this capital pi is the product of cos of x upon 2 raised to k, where k goes from 1 to infinity, and this small pi is we have its value. So this pi and this pi are different. Okay. Now in order to solve this, let's see, let's target this first. What is this first? Let's expand this. So let's consider this part. Let's consider pi of cos of x upon 2 raised to k, where k goes from 1 to infinity. Now let's substitute over here. So I am considering only these parts. Okay. So this equals to, when k equals to 1, what we have? Cos of x upon 2 raised to 1 into when k equals to 1, when k equals to 2, what we have? Cos of x upon 2 raised to 2 and into cos of x upon 2 raised to cube and so on, what, up to infinity. Okay. Now remember we have this formula. Remember, what is sine of 2x? Sine 2x is what? 2 sine of x into cos of x, right? So from here, if I want to find cos x, what is cos x? Cos of x equals to what? Sine of 2x upon 2 sine of x. So if I use effectively this, here cos of x is over here, in each term over here, let's see what it comes. So this is equals to what? Instead of x, I have to substitute over here x upon 2 raised to 1. So this is same as sine of what? 2 into x upon 2 raised to 1 upon 2 sine of, what is x? Or x is what? X upon 2 raised to 1. What I am doing, just I am applying this formula over here, okay, for each and every term, into here I will get what? Sine of 2 into x is this, x upon 2 square upon what? 2 into sine of x upon 2 square into sine of 2 into here x is x upon 2 cube upon 2 sine of x upon 2 cube and then goes up to infinity. Let's keep aside this all 2 here. Okay, here let's keep aside all 2 here. Now these 2 and these 2 gets cancelled. So I write one step over here. So this is same as sine of x upon 2 sine of x by 2. Here if these 2 and these 2 gets cancelled, if I have sine of x upon 2 sine of x upon 2 square into here sine of 1x, 1 2 gets cancelled, x upon 2 square upon 2 sine of x upon 2 cube and so on up to infinity. This term and this term gets cancelled like this, and this term and this term gets cancelled. Similarly, all the terms will get cancelled, but these 2 will be remaining. Now if I want to write last term, what I will get? I will get is what? Sine of 2 into upon 2 raised to infinity upon 2 into sine of x upon 2 raised to infinity. Okay. So, but this term and that term will get cancelled, but the remaining term will be this term and this term, right? So this is equals to what? Sine of x upon 2 raised to 2, 2, 2 up to what? 2 raised to infinity into sine of x upon 2 raised to infinity. Sine of x upon 2 raised to infinity becomes 0. Okay, sine 0 is 0. Therefore, sine of x upon 0, it becomes what? Infinity. Okay. So, let's not consider about these terms up to infinity. Let's consider up to some finite terms. Okay. So, instead of this, what I can do is, I can write some finite terms. Sine of 2 into x raised to x upon 2 raised to k upon 2 sine of x upon 2 raised to k. Okay. Where k is what? K is finite number. Okay, finite number. Therefore, here what will is, here we will get k over here. Here we will get k over here. Okay. So here we will get k over here. Here we will get k over here. Okay. So this will go. So this k should tends to infinity. Okay. Therefore, limit of k tends to infinity, sine of x upon 2 raised to k into sine of x upon 2 raised to k. So we need to solve this. So this is what, this is just this part, right? Is equals to limit of k tends to infinity. Now this, when this limit is k tends to infinity, therefore sin x become what? Constant. So I can send outside sine of x outside here, limit of k tends to infinity. Here 1 upon 2 raised to k sine of x upon 2 raised to k. Now here, if I want to use what? L'Hospital rule. What is L'Hospital rule? The limit should be what? Plus minus infinity, or if it is either plus minus infinity upon plus minus infinity, or if it is 0 by 0, then we can use this rule. Okay. But here this is 1 by infinity. Okay. So instead of this, what I can do is, I can bring this up. Here sine of x, limit of k tends to infinity. So I can bring up this same as 2 raised to minus k upon sine of x. I can write like this also, 2 raised to minus k, right? So now it is already from infinity to infinity. So now I can apply L'Hospital rule. Okay. L'Hospital rule means what? We have to differentiate. If it is f of x upon g of x, then we need to differentiate what? Numerator differently as well as denominator differently. Here you cannot use u by v rule, or you can say quotient rule over here. Okay. For L'Hospital rule, you have to differentiate whatever denominator you have denominator, what you have numerator, you have numerator in a straight way. So now let's differentiate this with respect to what? K. So this is same as, I will write over here, sine of x. I am differentiating this with respect to k. So I will get minus k into 2 raised to minus k minus 1 upon what? Here differentiation of sine is what? Cos. Cos of x into 2 raised to minus k. Again I need to differentiate this with respect to what? With respect to k. Okay. So if I differentiate this with respect to k, now x become a constant, x. Again differentiate this with respect to what? With respect to k. So I'll get minus k into 2 raised to minus k minus 1. Okay. Now this term and this term gets cancelled. Here I forgot to write over here. Here we have limit of k tends to infinity. So here we have sine of x. Now these two gets cancelled. What we have is, when k tends to infinity, this becomes 0. Okay. Cos 0 is what? Cos 0 is 1. So with this become 1, and what we have is, we have only x. Okay, so we have only 1 by x. So we have sine of x upon x. Therefore, this part, whole this part become what? Whole this part become sine x upon x. Integral 0 to pi by 4. What we have? X into sine of x upon x dx. So x gets cancelled. So we have the integration of sine x is what? Minus cos of x, limit is from 0 to pi by 4. So upper limit minus lower limit, minus cos of pi by 4 minus cos of 0 is minus cos pi by 4 is cos 45 is 1 by root 2, cos 0 is minus 1. So if I send this here, 1 minus 1 by root 2. Okay, this is the required answer for this.